have to wait for it to be. Need 2 minutes?
No, we're good.
Give me 1 second.
Yeah, no worries.
Okay. Oh no. Not again.
We're fine. Okay. Hello, everybody. Good afternoon. My name is Graham. With me is the lovely partner, Chill. We are here to talk today about our TPJ 655 final project, the awesome Cenobot 3000, also known as the checkers playing robot arm, utilizing vision capture technology, or the vision capture system. Vision capture system.
Is that an acronym?
Nope. It's just that was the old name, and we decided to narrow it down a little bit to a much better name.
As you can see, this one, you guys really familiar with this because a couple minutes ago, and somebody already represent. But this is not the same as us, and not same as the other group, because this is not our project. This is our path. Okay, so basically, after our presentation, you're gonna know that how the robotic arm works and how the interface with software and how do we do it in the C+ program. And so basically, what our project do is the user interconnect in the program and then to make the robotic arm moves, and then we have a camera that capture the location of each pieces, and also analyze the color of the pieces. So what we have is a robotic arm and one checkerboard and one PC and also a camera. This is what you see from okay. So the software we're using, there's one is Acting SE software. This one is default software, comes with robotic arm. It simulates the hardware with software together. And the program that we're building, we're using C++. The second arm is a heavy girl with her pad. Okay, so each robotic arm have a 7 joint and 1 gripper. To move the robotic arm, you need to set certain value to each joint, and then to change the speed, you can also choose you want the robotic arm doing faster or slower. For us, each joint is 1.5 seconds. And the number of the joint represents the position of the joint angle. And the picture on the left is the power supply for the robotic arm, and also middle one is the camera, and the last one is our awesome handmade checkerboard by Graham. He's gonna introduce this.
I made it of cedar and walnut. Back to you.
That's all?
Yep.
All right. And also the pieces.
Oh, the pieces as well. We decided to use crokinole pieces. If you've ever played with those, you'll know they're a little bit different than checkers pieces in that they're kind of rounder. Crokinole is meant for the flicking, so it's a bit softer. So the advantage to this is that when you are trying to use the robot arm to come down and pick up the piece, the rounded edge actually gives it a little bit of give. So if you miss the piece by just a little bit, it'll push it into the center of the gripper.
I think it's easier for this gripper pickup part. It's easier than rectangular and all the part they are doing. And for the software, Acting SE software is the simulation software for the robotic arm. And it looks like this. So what they can do is you can manually change the position of the robotic arm, and it will record the pass and replay the pass, and also to tell you the value of each joint angle. And there's a little video to show you how.
So the purpose of this is just to show how, as the robotic arm moves, it's synchronized directly with the software. So it's important to know as well that the software represents it as the hardware happens. So it's not the software moves it and the arm tries to match it. It's wherever the arm is, it sends those values to the software, and that image represents where the hardware is in real time. So if you tried to move the arm and you held it in place and wouldn't let it go, that image would show where the arm is you holding it.
So that's how the other arm got broken.
It was a funny, it was messy. You know, Rocket Talking Robots was our original project. Okay, so now I'm going to talk a little bit about the software and how it interfaces with the hardware. So when we began the project, we originally tried to use it entirely in ActinSC, but that turned out to be quite difficult. So we opted instead to move into Visual Studio 2010 and use C++. What is nice about the software included with this robot is that it comes with a bunch of pre-built programs. So one of them was hardware test. So what it does is it sets all the joints up to 0, 0, 0, which is this position right here, and then it sets everything to maximum. So it's one full complete function tied up nice and neat. Since, as Jatin and Jorge already mentioned, we didn't have a whole lot of experience with robots prior to this project, we found that to be incredibly helpful because we were able to look at this code and find out exactly how you need to initialize all the libraries, how you had to initialize all the drivers, what variables were needed, etc. So we used this program as the shell and then just gutted it, took out all the code from inside of it, but we looked at how we needed to initialize the drivers, so we kept that part. Between each joint as well, we were having a couple of issues with it was executing all the commands at once, and that would cause a whole bunch of issues because, surprisingly, the order that the joints move in when using this robot matters a great deal. If you try to move one joint before the next joint's ready, then you'll crash into the board and things will get broken. And as the team mentioned as well, the default position here is 0, 0, 0, 0, 0. So everything that happens to be negative or positive is just variations from this point. So negative, say, could be this way, positive will be this way. So that makes making small tweaks a lot easier because you have a reference point to base the numbers off of. We also use a vision system. Like the other group, we are using OpenCV, which is an open source, free to use set of libraries, which we can use into either C++, C, Java, MATLAB, etc. Using the OpenCV libraries, we are able to find the screen location and save the location of every single piece into memory. We use this location to display on the screen, although the locations don't directly influence where the robot moves. That's all hard-coded into our code. But we are able to show where the pieces are on the screen from the OpenCV libraries and this webcam. Additionally, with the vision software, we need to set up the maximum number of objects. So if right now our board is calibrated to find pink and silver, these two pieces. However, we can only find 50 objects maximum, which is a lot more than we have here, but when you're trying to calibrate the system, you get a lot of noise and a lot of inputs begin to trigger thinking that it's filtered and accepted into our program. So we needed to set a noise limit saying that nothing more than 50, which is actually very small, is allowed on the screen. Otherwise, they'll get a too much noise adjust filter image. A little bit more on the vision system. We were able to, so we wrote all the code for the vision system, but we found one very neat piece of code which we incorporated. It's a free-to-use system which allows us to filter, use scales to filter instead of having to find each individual value. There's different scales. We're going to show you this later, but this uses hue, saturation, and value to locate the pieces, not only color. This provides a huge advantage because while there's a big spectrum of colors, there's also just as many hues of that color and just as many shades of a color. So this looks for the value and the exact strength of each color. Then we save that image to the matrix and recall it later on in the code. So this is an example. This picture here shows what happens when we first load up the program and there's way too much noise. So it's a little cut off here, but it says too much noise, adjust filter, and we set up a grid here system just to line up to correct the calibration mode. So that is 0.0 when we begin. When we finish, however, we use these sliders and you filter out only the pieces you want. So if you notice here, these pieces correspond to the pink pieces. So that is the values here. We'll filter out this color exactly. So as you know, we're playing checkers. It is a game, so you need to have a way to interface with the game. First option is to choose the number of players. Unfortunately, there are only 2 players allowed at the moment, so you can choose 2. Or two. Then we also input player names because we wanted to have it so, like when we play, it's me against Chill. When I beat Chill, I want to know I beat Chill. There can't be any in between or whatever.
But that's never going to happen.
So I haven't been here yet. I haven't been here yet, but one day when I do, it will be awesome. So everybody takes turns. In between turns, the player's turn changes at the top of the screen. There's an option to surrender, and you can see which pieces are available on the board. And there's an exit. Not that you ever want to quit, but if you do. Yeah. So these are the options we have. It's Chill's turn. Chill versus the world. You can take your turn, locate pieces on the piece using camera, surrender angrily, or So this is the summation of our PowerPoint, and then we're going to do a demonstration for you all as to how this software exactly works, because it will take a little bit more time than a lot of other ones. So before we get into that, does anybody have any questions about the PowerPoint or how we got numbers or stuff? No? Okay. Somebody turn on the light, please.
You think the light
Well, yeah.
more like that?
I do have a question.
Oh, yeah.
The pieces, the last week they talked about the positioning of pieces. So you said that your positions are pre-calculated?
Yeah, everything's hard-coded.
Okay,
So this board cannot move.
okay.
We were able to, towards the very end of the project, get it so we can save the locations into a matrix and output them. But at that point, we'd already hard-coded in all the locations. So it was kind of like, we were very glad to have that happen, but it came about too late.
And then one other question. You hand-made the board. Did you hand-make the board specifically so you can get the right size and the right shape for?
I hand-made it to pass grade 10 woodshop.
Nice.
All right, so first of all, since we have a little bit of time, we're gonna choose a calibration mode just to see.
So this is our calibration mode that we mentioned earlier. Since the lighting's different than in the room where we tested it, the filter may not work properly. So we're going to take you through how we calibrate. It only takes a second.
I hope so.
Or, more.
Okay, so how many players do you want? Two.
Which is Chinese for two.
Oh, so this is a calibration mode, so don't worry about this for now. Let's just try to get the
We're off by a little bit. It changed that much just from here to here.
So we have a rectangular and 2 lines to line up the position, and something like that.
That's good. So this is the filtered image. So right now it's letting everything through. We want to get it so we only see white dots for each color. Silver, the colors for our silver was, the minimum was 0, the next minimum was 0, the next minimum was 146. So we should crank this up to 146-ish. Enough. You can see we're already beginning to see the pieces come out up there. Then we do the maximums. The maximums are 128. I had it and I lost it. 26. See, so it's different already.
We should return some light check?
Do the light.
Is that
That's
right?
Probably. We just get chill, let somebody else do it. Okay, stay.
So it just requires a little bit of fidgeting.
There, right there.
That's good.
You don't want the lamp on, eh? The lamp doesn't help?
No, because we did it without the lamp. There.
There you go.
I think those numbers actually might work.
What is it?
Well, since one person moved, all of the lighting changed.
Yeah, it is quite
The
sensitive.
thresholds are different.
Is my shoe? So in our room, yeah.
But I guess you guys get the idea, so let's move on.
Sure.
Could you please turn on the light, please?
You don't have to move everything, right? You just have to move a couple pieces.
Yeah,
right?
Yeah.
great.
It seems like you can see a couple pieces there, no?
Yeah. Yeah. So everything will work for moving the pieces since it is hard coded. The only issue is the camera may not pick up all the pieces.
Okay.
But I
We see
cross
the-
my heart it works in the other room. Scout's arm or something. So we turned off calibration mode, now we can play the game.
Alright, so 2 players. Who wants to play? Alright.
Okay.
Shannon?
Nishani?
Yes.
Me. And the other player is me. Okay, so normally this would happen across everything. This would occur across all the pieces here. This one did filter through properly, so you'd have a little pink above each pink piece with the square it's on. So this is H2. This one, it's able to show the thing, but normally it would say silver below here.
You gonna try the light?
That's not okay, it is Nishani's turn. So you have options. You can take your turn, or you can locate pieces on the PCs and camera. Which one?
Now you can just tell
Yeah.
us. Oh,
So
okay.
press it one. Yep.
Surrender.
So player one is pink.
Player 1 is pink.
Okay. So that's the old B2 to A3 move. It is classic and a very strong move. So that will move. Can you guys see it?
So the robotic arm is moving right now.
Yeah, so if you guys can't see, come hither. And this isn't quite in the center, sorry. So I'm not cheating, I'm just putting it in the center. Oh, it wasn't lined up. It bounced in the cart.
You got it?
They got it, but. So between every move, it goes up to default position. We had issues originally because we were trying to have it pick up a piece and then move it without going to default position. But when you have the really drastic moves across the board, the angle of the joint movements matters a lot. So the joints all have to move from this position to not crash into the board.
After it come back,
And then Nishani finished her turns. I keep thinking it's that keyboard. Nothing. We have it set up so if you captured pieces along the way, you would enter which pieces you took, and then the robot would pick them up. But she did not pick any, so I'm going to put 0. I'm going to move my piece from.
oh, now it shows.
Oh, now it's
Ah, don't move.
You're welcome. I'm going to take my turn, and I'm going to do a very quick move of something with something. G7 to H6. Oops, sorry. It's a little bit off. So it's, well, this might be a violent one. You know what? I don't like that move.
It's not identifying the white pieces, you can't see them?
It can in the room, but not here.
Ah, okay.
That would be perfect.
That wouldn't work well.
That looked amazing.
It just doesn't like you.
So for a really really does look. So just to show, I'm gonna, because I failed at that, I'm gonna capture one of my own pieces, and then we're gonna that'll be it.
That's good.
So which piece are we gonna capture? A7? Or how many pieces? Sorry, one. What piece? A7. There's a small error with it. That happening twice. Click down.
Yay!
We're supposed to
You have a bucket, but it doesn't fit.
pew on my hand.
Drop.
Bravo.
And then the other option was Nishani, obviously intimidated by my strategic prowess in this game, gives up. So I win. Nishani loses. And then we'll show one more move. Sorry, the last one, which is funny. It's worth it. I hope this works out. How many players? 2. This player's 1's name. Nishani again. Shows up pink, that's good. Okay, and I give up immediately. She is too good, so I'm going to surrender angrily.
Are you guys ready?
Yeah.
All right.
Shiny wins. Graham must be really mad. Thank you very much. That's a good.
Well done, guys.